Hello everyone, this is Data620 Project 3 presentation. My name is Mahmoud Hassan Al-Raji and I worked alone in this project. Here are the project details. In this project, basically I built a name-based gender classifier using a naive Bayes algorithm. To improve the classifier, I tried different features, sets, and evaluated each one on the depth test set to identify the best performed feature combination, and based on those results I selected the final features and then tested the classifier on the test set. In this project, basically I used names corpus from analytical libraries, and then I divided the files into three subsets: 500 names for the test set and 500 names for the depth test set, and the remaining 6,900 names for the training set. And after building the final classifier, I made a comparison the performance of the classifier on the test set and on the depth test set, and then finally I made my expectation discussion at the end of the project. So here are the libraries that I used in this project, and I'll take a random and other features or functions from those libraries. And then I downloaded the names dataset, and then I level each name as male or female and then mix them together. After that, I shuffle the data to make it random. And as you see that finally I divided the dataset into three parts, and then I created three simple functions that basically define different ways to extract features from a name for gender prediction. The first function features last letter, uses only the last letter of a name since it often indicates gender. For example, names ending in A are usually female. And the second one features first last, uses both the first and last letters to capture more information from the name. And the third function features suffix, focuses on the last one, two, and three letters, which often show strong gender patterns like IE or son. And then I improved the classifier gradually using these different feature sets and tested each version only on the depth test set to track progress and find which combination predicts gender most accurately. Here we see the training and the evaluation process on the depth test. To do that, basically I defined a function called evaluate depth test to train and test the classifier using different feature sets. The function first creates a training set and a depth test set by applying the selected feature extractor to the names. It then trains a naive Bayes classifier on the training set and checks its accuracy on the depth test set. The function prints the feature set name and its accuracy score so that I can compare different models easily. So as you see here that the feature suffix based function got the highest accuracy of 0.776. So based on this accuracy score, I selected the feature suffix based classifier as my best performing model on depth test set. And then finally I evaluated the classifier on the test set, and as you see I got an accuracy score of 0.784, which is slightly better than the score that I got on the depth test set. And also you see I computed most informative features uh, and which basically reveal strong patterns such as names ending in NA, LA, IA being mostly female, while names ending in K or US are more likely male. So this confirms that suffix patterns are very helpful in predicting the gender of names. So with this result, I am very satisfied with the suffix-based classifier since it achieved the highest accuracy among all versions on the depth test set. As I mentioned already that when I compared the accuracy score, I found that the accuracy score slightly increased from 0.776 on the depth test set to 0.784 on the test set. So, though the results are very close, but still it's showing the model generalizes well and does not overfit the data. So then I also computed a couple of performance matrices like confusion matrix. I also computed recall F1 score precision for both the test set, for both the depth test and test set. And what I found that the F1 score increased from 0.81 for male on the depth test to 0.83 for male on the test set. The confusion matrices also show fewer mistakes in the final test set. For instance, that 61 female names were misclassified as male in the test set compared to the 74 in the depth test set. So, as a whole, this small improvement is expected because the model was tuned using the depth test set, and the similar results on the test set show the classifier generalizes well and is not overfitting. So this result was expected because both datasets come from the same source, and it confirms that the classifier performs consistently on new unseen examples. So in a summary, I would say that I'm very satisfied with this result, and the result was expected. So thank you so much for listening to me.